So this last video is about dilutions, and the equation for dilutions is going to be very familiar. It's M1 V1 equals M2 V2. Looks a lot like our Boyle's law from gas laws, where it was P1 V1 equals P2 V2. But of course, this time we're using molarity and volume instead of pressure and volume. But this way, if you're taking a look at a solution where it's too concentrated and you need to water it down, you need to dilute it, you can make this calculation to figure out how much of the original solution and how much the final volume needs to be in order to make a final molarity. Chemists do this a lot in the laboratory because we often start out with concentrated solutions and then water them down or dilute them to the right concentration. So in our example here, it says how much 2 molar sodium chloride solution would you need to make 250 milliliters of 0.15 molar sodium chloride solution? So our initial molarity is 2 molar, and it says how much of that. So our initial volume is going to be our question mark. If you notice in the language, it's 250 milliliters of 0.15. These two things are going to go together. This volume and this molarity will be V2 and M2, or V1 and M1. It really doesn't matter as long as they're matched together. So our final volume is going to be 250 milliliters, and our final molarity is going to be 0.15 molar. So we set up our equation, M1 V1 equals M2 V2. We're going to rearrange this because we're looking for V1. So we divide both sides by M1. Oops, I'm crossing out the wrong one there. We know what I mean. V1 then is going to be equal to M2 V2 over M1. So now I can put all my numbers in here. So 0.15 molar times 250 milliliters. And yes, you can use these volumes in milliliters as long as both the volumes are in milliliters. So as long as milliliters and milliliters match, or liters and liters match, it doesn't matter what the units are as long as they are the same. And then M1 is going to be 2 molar. So we multiply the top and then divide by 2, and we end up with, I believe your calculator says 18.75. We're going to round it to 19 milliliters since we only have 2 significant figures. So again, these equations are a little familiar, just with a little bit different units, but it looks a lot like the calculations we did in gas laws.